Hello guys, welcome to my GLPK tutorial. In this video, we will solve our first problem by maximizing the profit of our imaginary steel production factory. First, we will define our problem, and then we will derive mathematical equations from given problem, and we will implement these mathematical equations in GLPK as simple as possible, and at the end, we will display our results. And in the next video, we will learn to separate the data and the model to create more generalized problem model. And also we will improve our new model in terms of syntax and simplicity. Let's discuss our first problem. We have a steel factory, and in this factory we are producing two different kinds of products. Our first product is steel bands, and profit per 1 ton of steel bands is $25. And time to produce 1 ton of steel bands is 1 divided by 200 hours. And maximum amount of steel bands we can produce per week is limited by 6,000 pieces. And our second product is steel coils. And profit per 1 ton of steel coils is $30. And time to produce 1 ton of steel coils is 1 divided by 140 hours. And maximum amount of steel coils we can produce per week is limited by 4,000 pieces. In addition to this, in our factory, our available production time per week is 40 hours. The question we are trying to answer is how many bands and coils should be produced for achieving maximum profit. After defining our problem, now we can start the model and derive equations from it. We are trying to find how many tons of bands and how many tons of coils we should produce for maximum profit. Let's assume number of bands for maximum profit is XP, and let's also assume number of coils for maximum profit is XC. With the help of these two variables, we can find total production time needed in our factory to produce all these products. In order to calculate this, we just need to multiply products with their production time and add them to each other. And as a result, we will get this equation. And in the question, it is denoted that maximum production time can't exceed 40 hours. So our final equation will be like this. And also we know the maximum production limit per product. Amount of bands cannot be bigger than 6,000 pieces, and amount of coils cannot be bigger than 4,000 pieces. Lastly, question is asking us to find how many number of coils and bands should we produce to achieve maximum total profit. And this requires us to formulate the total profit. And we can calculate the total profit by multiplying product amounts by their profits and add them to each other. We already know that profit per bands is $25 and profit per coils is $30. So this will be our final goal equation that we are trying to maximize. If we summarize, we have two variables, XP and XC, and we have one goal equation which we are trying to maximize, and we have three limitation equations about total time limit, max production limit of XP, and max production limit of XC. And with these four equations, we fully defined our problem and we are ready to implement and solve our problem with GLPK. So let's create a new file here and let's call it lesson1.mod and let's open it. As we talked, we have to create two variables, and let's call our first variable XP and our second variable will be XC. Let's write our goal equation here. It is 25 multiplied by our first variable plus $30 multiplied by our second variable. And we are trying to maximize this equation, so we can just say here maximize, and we have to give a name to this equation, and we are maximizing our profit, so we'll just gonna say like profit to here, and we'll just gonna put semicolon here. And let's write our limitation equations. This is our first limitation. To tell GLPK this is a limitation equation, we'll just gonna say subject to, and we'll give it a name. Let's say it's total time per week. And I forget this in here also. Yes. And let's write our second limitation equation. Let's name it B limit. and the last one is for C, and it will be XC here, and it will be 4000. And then all we have to do is to tell GLPK to solve these equations, and it will solve it for us. So let's save this one, and let's run our file. Let's open the folder. We will hold Shift and right click and open the Windows PowerShell here. We'll run. Let's see GLP sol model lesson 1 .mod. And when we run this code, we will see optimal LP solution is found, but we don't see any output here. Like these are process of the GLPK, but we don't see the real results. So we have to display our results. So let's go to our code again. After the solve, let's say display XP, and let's rerun it. And as you can see here, display statement at line 14, XP value is 6000. So let's do this for also XC and also profit that we calculate as a goal function, goal equation, yes. And if we run it again, you will see that in our optimal solution, XP is 6000, so we are producing maximum amount of XP, and in XC we are producing only 1400. And in this case, our profit, which is also maximum profit possible, will be $192,000. But this kind of output is not always what we want. Sometimes we need more explicit and more beautiful outputs. So let's use something else here. We can make use of printfs to make pretty and more meaningful outputs. So let's print our XP. And we can do this for the XC. And also for our profits. Yes. And let's save it and let's rerun our code. And as you can see here, it's more pretty and we can see the results in a better way. The real advantage of this kind of displaying, making use of printfs, will come handy later. Sometimes we don't want to just display one variable, but we want to display a variable in different kind of states, and we want to multiply different variables together and display their results. And this will be more handy to use when it comes to the complex problems. And that's all for this video.